in depth explained the first couple. And again, if you have questions, you can ask us during live tutorials, or you can even ask us on Padlet. A lot of people have already been using that. We thank you for that. All right, here we go. So we're going to interpret the parent function on this one in part C is going to be f of x is equal to 10 to the power of x. This is the parent function interpretation, okay? So let's go ahead and go through the list, and we're going to look at this minus 2, okay? And I'm running out of room, so I'm going to write it right here. That is a horizontal shift 2 to the right, because we do the opposite with x, okay? Then this negative 2, we need to look at as two different transformations, not just one, okay? So I want to look at the negative first, then we'll look at the 2, okay? So let's look at the negative first. This is a vertical reflection, or you could just say vertically reflects across. So if you're vertically reflecting, it's like you're jumping across the x-axis. Okay, and then next is this 2. Okay, so we're going to say 2 is a vertical, it's a vertical stretch by a factor of 2. Okay, and last but not least, we have this minus 5. Okay, so we've already done the 2, we did the negative, we did the 2, now we have this minus 5. And this right here is our D value, which shows our horizontal asymptote, whether it was shifted up or down. Okay, so it's a quick little view of, ooh, this is the horizontal asymptote. And this was a vertical shift, because it's adding or subtracting 5 units down, because you follow the rule. You don't do the opposite with y, you follow the rule with y. All right. So our key point, what would make our power equal 0? Okay, so right now our power is x minus 2, and obviously x equals 2 would make that become a power of 0. Okay, so let me go ahead and build our table. And starting at 2, because again, that's that x value that would make it 0, make the power 0, that is. Then it would be 2, or 2 minus 2 is 0. 10 to the power of 0 is 1. 1 times a negative 2 is negative 2. Minus 5 would give us a negative 7. So again, that negative 7, you see right now, it's not equal to 0. So it doesn't have to be that all the time. So our key point is to negative 7. Okay. And then we can just incrementally keep going. We have 2, then say 3, 4, 5. And again, I'm going to rely on my calculator, and I will remember this time to go back. I'm going to store this transformation function so that I can get my values from 2, 3, 4, and 5. Okay, so here we go. Menu, 1 for actions, 4 to clear storage, and press OK. That's going to come in handy very soon. Menu 1, 5 will clear your history. That's how you should clear your calculator. Menu 1, 4, OK. Menu 1, 5, between problems. Okay, here we go. Negative 2 times 10 raised to the power of x minus 2 minus 5 is all going to be control stored as your f of x. So f of 2 we know was 7, or negative 7. F of 3, f of 4, and f of 5. Okay, so these are pretty big numbers, okay? So we have negative 25. Oh, let me go back. We have negative 25. We have negative 205. And we have negative 2005. And again, this is growing fast, and you see it. And a big reason why is because the base was a huge number. So again, it's not doubling, tripling, or quadrupling. This one is multiplying by 10 each jump per se. All right, by a factor of 10 and more, okay? So let's go ahead and plot these points. We have 2, negative 7. So 2, negative 7 is about here. And then we have 3, is negative 25, so that's off the charts. So we want to concentrate real quickly on this negative 5. Okay, this negative 5, like we said before, is the horizontal asymptote being shifted 5 units down. Okay, so at negative 5, we have this horizontal asymptote. 1, 2, 3, 4, 5. Yep. And then the graph would look something like the following. It will approach and then take a nosedive. Okay, so this is a rough sketch per se. Let me see if I could do that just a little bit better. You're still going to approach the horizontal asymptote as you go to the left, and then it nosedives as you go to the right. It will go to the right forever. It just slowly goes to the right, but faster goes downward. Okay. All right. So there are the points that we have. If you want to try putting in 1 to see what would that value be, you can. That's fine. I mean, the more points you have surrounding this too, the better. But nonetheless, you want to really, at bare minimum, start from the key point and work your way to the right. All right, so the domain. The domain is all real numbers. The range, it looks like, are y's that are less than negative 5 or negative infinity to negative 5. Okay, because you go from low y to high y. And then again, in blue, our horizontal asymptote is going to be y is equal to negative 5. This is decay this time, okay? Because it is nosediving and actually going downward as you go. Actually, let me take that back. This is actually not going to be decay because decay would approach. This is very, very important. I'm glad I caught it and did not continue to record. It will approach the horizontal asymptote as you go to the right. So if I have a graph that approaches the horizontal asymptote like this, or it approaches it like this, that's kind of a form of decay, okay? But this one isn't doing that. This one isn't decaying, even though it's decreasing, okay? It's not approaching a horizontal asymptote. So this is going to actually be growth. Okay, and how do we know that? Because way back here, when we were talking about growth, we were saying that this b value, if it was between 0 and 1, it would be decay. And if it was bigger than 1, it would be growth. Well, 10 is obviously bigger than 1, so it is not decay. This is actually growth. All right, hope you got that. Feel like I'm glad I caught that and didn't keep going because I did not want to confuse anyone out there. All right, so let's go to D. We have 3 is multiplied, so this is like 3 times 1/3. So this 1/3, this is where B is between 0 and 1. Okay, it's a fraction that's in between, so we already know it's going to be decay. I'm going to do this a little bit in a different order. This is going to be shifted 2 up, so we know y is equal to 2. And the key point is going to be when this power is 0, which will start at 1. Okay, so 1 minus 1 is 0. 1/3 to the power of 0 is 1. Times 3 is 3. Plus 2 is 5. Okay, let us now go to graph it with, first of all, listening to transformations, then we'll go to graph. So let's work with this 1 up here. This one was a horizontal shift 1 to the right, 1 unit to the right, because you do the opposite. Okay, our second one is our A value. So again, this was the C, this is going to be the A, whoops, and this last one will be the D. So our A value is going to be a vertical stretch by a factor of 3. And then last but not least, our D value of plus 2 is showing a vertical shift 3 units up. Follow the rule because it's not with the X. All right. So let's go ahead and get some points going as far as a table is concerned. So let me move this table. Actually, I will just use the same table, but I'm going to erase because you guys probably have it in your notes already. And then let me go ahead and move this over just a little bit because I'm going to use it for this other graph here. Well, we know it starts at key point x is equal to 1, and then just start making values like 2, 3, 2, 3, and 4 if you want. And then now when we plug them in, we can go back to the calculator. Again, what do we put in the calculator? The transformation function. Here we go. So just like good practice, menu 1, 4, menu 1, 5. We're going to go ahead and plug in 3 times. Okay, so let me get this fraction going on. I can press this and then this one, or quick hotkey go control divide. Okay, so we have 1 over 3, close parentheses, is raised to the power of x minus 1. Whoops. Then kick off to the right so you can jump down and do plus 2. And this is going to be control store our f of x. So we have f of 1, f of 2, f of 3, and f of 4 are the following points. Okay. Now these gave you nice fractions, but if I clicked on it again by pressing enter and then did control enter, so the blue button enter, it will give me a decimal. So let's get this f of 4 to say control enter. It will also give me a decimal. So right now I'm telling you, control enter is a huge thing that you need to get used to, especially in this unit because we're dealing with a lot of decimals. Okay, so f of 1 gave us 5, and then f of 2 gave us 3, and then we have 2.3 repeating. I'll switch in a minute, the screens, and then 2.1 repeating. Let me show you what that looks like. So we want to put 2.333 with a bar over that last 3, saying that it's just repeating forever. And then 2.111 with a bar over that 1, showing that it will repeat the 1s forever. That's the proper notation mathematically. Okay, so let me come over here and let's make some room. Let me kind of condense our transformations. And we're going to make some room for our, whoops, something I forgot real quick. Our parent function for the one we're currently working on. It is a decay, just like the other one was a growth, because our base was between 0 and 1. So it would be 1/3 to the power of x. That is our default parent function, okay, for this right here. All right. So let's go ahead and graph this. We have 1, 5, 1, 2, 3, 4, 5. I have 2, 3, so 1, 2, 3. Then I have 3, so I'm doing these points right here. I have x value is 3, then 2.333, then 2.111 at 4, and you're seeing we're getting very, very close to 2, but without touching, okay? So it does look something like, whoops, let's take that back, something like this, and then it kind of will approach. Y is equal to 2 because we know that's our horizontal asymptote. A lot of this kind of starting to click and make sense by now, I'm sure. I don't want to go too fast because we're e-learning, but at the same time, those who might be struggling, I want to over-explain things early in the unit, then under-explain things early in the unit. We can pick up speed later, okay? But there's my function. So let's go to the domain. The domain is all real numbers, as you can see. It'll go to the left slowly each jump, but it will go to the left forever as it goes up. And then as it goes to the right, it will go to the right forever. That's why it's all real numbers, okay? And then y is greater than 2 or 2 to infinity. Don't touch 2, so let's put a parentheses. And there are the pieces, okay? So let us see now. I believe we're going to just keep going and finish off this page. Again, I do apologize. This video is a little bit long, but you are able to pause, record, or pause, rewind, fast forward, however you need to in order to ensure you get the knowledge. All right. So here we go. E, the parent function, I'm going to kind of pick up my pace now, is y is equal to 1/2 to the x. Okay, that means I have 1, 2, 3, 4 transformations. Again, that 1/2 base has nothing to do with transformations. Okay, So our transformation that's listed first is that plus 3, because we're doing CAD order. So we'll say it's a horizontal shift 3 to the left, 3 units left, because it's opposite. That's just a left arrow. And then our second transformation is this negative, and it is vertical. So you don't have to say vertically reflects. You could just say it reflects across the x-axis. Just make sure you say the right axis. Don't say vertically reflects across the y, because you can't do that. That's impossible. You vertically reflect across the x-axis, or you horizontally reflect across the y-axis. All right, so now let's look at this 4 right here. So it's going to be a vertical stretch. So vertical, that's how you spell vertical. Vertical stretch by a factor of 4. And then last but not least, this other 4 is going to be a vertical shift 4 units downward, because you follow the rule whenever it's with y. All right, so our key point we know is going to be -3, because it would make the power 0. So 1/2 to the 0 is 1, because anything to the power is 1. Times the -4 is -4. Minus 4 more would be a -8. Okay, so -3, -8 is my key point. And let's go to make a quick table so that I can get the other values. All right, so let's go to make this quick table. Actually, you know what I'll do? I will go ahead and put this into the calculator. So menu 1, 4, okay. Menu 1, 5. -4. Oops. Let me put it like this. -4 times control divide. Whoops. 1/2, close parentheses, raised to the power of x plus 3. It's going to be -4. And it's going to be stored as, I know it says y, but we need to variegate it. So we need to have a variable of some kind. We can't just put stored as f. It needs an input variable so that we can use this feature. So we're going to start at -3 and then start going up by 1 each jump. So -2, -1, then like 0. Okay, so there's a fraction here, so I will control enter to get that fraction, which is -4.5. And let's start putting in these points. -3, -8. Okay, so -3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. It's way down here. Okay, and then we go back to -2, -6. So 1, 2, 3, 4, 5, -6. Then -1 is x, -5 is y. So 1, 2, 3, 4, 5. And then we have 0 at -4.5. So -1, 2, 3, 4.5 is about here. And you can see the horizontal asymptote is going to be y is equal to, let me write that up here, is going to be y is equal to -4. All right, so horizontal asymptote. Let's go ahead and draw that out real quick. All right, so -4 is going to be here. It's the dashed line that the graph will approach, but never hit as it goes to infinity or -infinity. And therefore, the graph will look something like the following. Let me see if I can get this. So here, and then it will hug and get close to infinitely, but never actually hit. The domain, the domain is all real numbers. The range looks like it's y's that are less than -4, or -infinity to -4, not touching -4. Remember, least to greatest, lowest y value to highest y value. And this, because this b value is between 0 and 1, is decay. Okay, even though it's increasing as you go to the right, it's not increasing forever. It doesn't go off to infinity. Okay, that would be growth. This increases because it's going up as you go to the right, but then it tapers off okay, to this horizontal asymptote, and it levels off. That's not growth. When it levels off like that as you go to the right, that's not growth. That's decay. Okay. All right. So let's see what else is